Hello everyone, here you are going to learn about GSM. With this video, you will able to get basic knowledge about GSM. I am Pawan Chirantha, the author and presenter of this video. Here we go for Global System for Mobile. In this learning aid, I am got three main categories to describe GSM. They are what is GSM, GSM architecture, GSM interfaces. First of all, we will find what is GSM. What is GSM? There are two main mobile systems for mobile communication. The first one is GSM, Global System for Mobile. The second one is CDMA, Code Division Multiple Access. The Global System for Mobile Communication is a standard developed by the European Telecommunication Standards Institute to describe the protocols for second generation 2G digital cellular networks used by mobile devices such as mobile phones and tablets. It was first deployed in Finland in December 1991. Simply, the GSM is a big system that made by few main small systems with communication components. They are MS mobile station, BSS base station subsystem, NSS network switching subsystem, OSS operation and support subsystem. Okay, let's go back to main menu. Secondly, I am going to describe about GSM architecture. This is a simple structure for GSM architecture. This overview might be difficult to understand for who new in this lesson. You will be thinking about what is MS, BSS, NSS and OSS. There are four main subsystems in GSM and I will explain one by one for you as in 4 steps. Okay, let's start the first step. MS, mobile station. Mobile station, mobile equipment, or as they are most widely known, cello, mobile phones are the section of a GSM cellular network that the user sees and operates. There are a number of elements to the cell phone, although the two main elements are the main hardware and the SIM. The hardware itself contains the main elements of the mobile phone including the display, case, battery and the electronics used to generate the signal and process the data receiver and to be transmitted. It also contains a number known as the International Mobile Equipment Identity (IMEI). This is installed in the phone at manufacturer and cannot be changed. It is accessed by the network during registration to check whether the equipment has been reported as stolen. The SIM or subscriber identity module contains the information that provides the identity of the user to the network. It contains the variety of information including a number known as the International Mobile Subscriber Identity (IMSI). This is the position of MS in GSM architecture. Okay, let's start the second step. BSS, Base Station Subsystem. The Base Station Subsystem (BSS) section of the GSM network architecture that is fundamentally associated with communicating with the mobile on the network. It consists of two elements. First one is BTS, Base Transceiver Station. Second one is BSC, Base Station Controller. Sum of these two elements, it is the BSS. BTS, Base Transceiver Station. The BTS used in a GSM network comprises the radio transmitter receivers and their associated antennas that transmit and receive to directly communicate with the mobiles. The BTS is the defining element for each cell. The BTS communicates with the mobiles and the interface between the two is known as the UM interface with its associated protocols. I have star marked in here UM and other interfaces. They will be discussed from next slide in GSM interfaces. BSC Base Station Controller. The BSC forms the next stage back into the GSM network. It controls a group of BTSs and is often co-located with one of the BTSs in its group. It manages the radio resources and controls items such as handover within the group of BTSs, allocates channels, and the like. It communicates with the BTSs over what is termed the abyss interface. This is the position of BSS in GSM architecture. NSS Network Switching Subsystem. Main part of NSS is the Mobile Switching Center (MSC). This performs the switching of calls between the mobile and other fixed or mobile network users, as well as the management of mobile services such as authentication. These are the five elements of NSS. MSC Mobile Switching Center, HLR Home Location Register, VLR Visitor Location Register, AUC Authentication Center, EIR Equipment Identity Register. Okay, now let's we discuss about five elements in NSS. First one is MSC Mobile Switching Center. The central component of the network subsystem is the MSC. The MSC performs the switching of calls between the mobile and other fixed or mobile network users, as well as the management of mobile services such as registration, authentication, location updating, handovers, and call routing to a roaming subscriber. It also performs such functions as toll ticketing, network interfacing, common channel signaling, and others. Every MSC is identified by a unique ID. HLR Home Location Register. The HLR is a database used for storage and management of subscriptions. The HLR is considered the most important database as it stores permanent data about subscribers, including a subscriber's service profile, location information, and activity status. When an individual buys a subscription in the form of SIM, then all the information about this subscription is registered in the HLR of that operator. VLR Visitor Location Register. The VLR is a database that contains temporary information about subscribers that is needed by the MSC in order to service visiting subscribers. The VLR is always integrated with the MSC. When a mobile station roams into a new MSC area, the VLR connected to that MSC will request data about the mobile station from the HLR. Later, if the mobile station makes a call, the VLR will have the information needed for call setup without having to interrogate the HLR each time. AUC Authentication Center. The Authentication Center is a protected database that stores a copy of the secret key stored in each subscriber's SIM card, which is used for authentication and ciphering of the radio channel. The AUC protects network operators from different types of fraud found in today's cellular world. EIR Equipment Identity Register. The Equipment Identity Register (EIR) is a database that contains a list of all valid mobile equipment on the network, where its International Mobile Equipment Identity IMEI identifies each MS. An IMEI is marked as invalid if it has been reported stolen or is not type approved. Okay, we already know about MS and VSS in past steps. Now we will see the position of NSS in GSM architecture for third step. Now we are going to discuss about a main subsystem in GSM as the fourth step. OSS, Operation and Support Subsystem. The OSS or Operation Support Subsystem is an element within the overall GSM network architecture that is connected to components of the NSS and the VSC. It is used to control and monitor the overall GSM network, and it is also used to control the traffic load of the VSS. It must be noted that as the number of BS increases with the scaling of the subscriber population, some of the maintenance tasks are transferred to the BTS, allowing savings in the cost of ownership of the system. This is the position of OSS in GSM architecture, and we have completed the fourth step. Already, I have learned the basic GSM architecture using those four steps. Now, let's go for main menu for the rest. Let us discuss about GSM interfaces as our third main category. GSM interfaces. The network structure is defined within the GSM standards. Additionally, each interface between the different elements of GSM network is also defined. This facilitates the information interchanges can take place. It also enables to large degree that network elements from different manufacturers can be used. However, as many of these interfaces were not fully defined until after many networks had been deployed, the level of standardization may not be quite as high as many people might like. This is the full overview of GSM interfaces. There are many interfaces in one structure. Oh, don't be worried. Let us describe one by one for you. interface, the air or radio interface standard that is used for exchange between a mobile and a base station BTS PSC for signaling. Abyss interface. This is a VSS internal interface linking the BSC and BTS, and it has not been totally standardized. The Abyss interface allows control of the radio equipment and radio frequency allocation in the BTS. A interface. The A interface is used to provide communication between the BSS and the MSC. The interface carries information to enable the channels, time slots, and the like to be allocated to the mobile equipment being serviced by the BSS. The messaging required within the network to enable handover, etc., to be undertaken is carried over the interface. B interface. The B interface exists between the MSC and the VLR. It uses a protocol known as the MAP-B protocol, as most VLRs are collocated with an MSC. This makes the interface purely an internal interface. The interface is used whenever the MSC needs access to data regarding a MS located in its area. C interface. The C interface is located between the HLR and a GMSC or a SMSG. When a call originates from outside the network, from the PSTN or another mobile network, it has to pass through the gateway so that routing information required to complete the call may be gained. The protocol used for communication is MAP-C. The letter C indicating that protocol is used for the C interface. D interface. The D interface is situated between the VLR and HLR. It uses the MAP-D protocol to exchange the data related to the location of the MS and to the management of the subscriber. E interface. The E interface provides communication between two MSCs. The E interface exchanges data related to handover between the anchor and relay MSCs using the MAP-T protocol. F interface. The F interface is used between an MSC and EIR. It uses the MAP-F protocol. The communication along this interface are used to confirm the status of the IMEI of the MS gaining access to the network. G interface. The G interface interconnects two VLRs of different MSCs. It uses the MAP-G protocol to transfer subscriber information. Example, a location update procedure. H interface. The H interface exists between the HLR and AUC. It transfers short messages and uses the MAP-H protocol. Thank you for all who watching my video. I hope you have learned something from this. I am Pawan Chirantha.